Hello, amazing learners. You're welcome to class. In today's class, we're going to be learning number bases. What did I say? Number bases. What is a number base? A number base refers to the system used to represent numbers using digits and place values. System used to represent numbers using digits and place values. We all know, the normal way of counting is called base 10. So in base 10, we use the digits 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So base 10, which is the commonest base we use, these are the digits that make up the number. So any number you're going to write in base 10, we have either of these digits, and it will not exceed 9. And we have other bases too. We have base 2, we have base 8. Base 2 is called binary. So our base 10 uses these digits. When you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digits. And remember, there must be 0. All number bases the digit starts with 0. That's why you can see that the number of the digit will be 1 and 10 and minus 1 of that base. So 10 minus 1 is 9. So our digits stop at 9 for base 10. Now for base 2, which we call binary, we call base 2 binary. It has 2 digits. It has what? 2 digits, and they are what? 0 and 1. Remember, all bases, the digits must start with 0. We have 0 and 1. So these are the 2 digits. So we have other bases. We have base 8, that's octal. Base 8, for the base 8, the digits are 0, 1, 2, 3, 4, 5, 6, and 7. That's for base 8. So in number base, we talk about the system used to represent numbers using digits and place value. When you talk of place value, look at this number, 625. And we have all learned about place value. What is the place value of 5? 5 is 5 units. 2 is 2 tenths. While 6 represents 600. So based on the position of numbers, the digits has its own value. So if this 6 were to be here, it should be units. And can you just pick it that units, each of these place value is as a result of power of 10. Power of 10, because this is a base 10. For units, the power of 10 there is 0. For tens, the power of 10 is 1. For 100, the power of 10 is 2. So when we look at it, this one is 5 times 10 raised to the power of 0. When any number is raised to the power of 0, that number is 1. So that means 5 times 1 is equal to 5. These two represent 20. That's why I say 25. And it's 2 times 10 raised to the power 1. 10 raised to the power 1 is 10. 2 times 10 is equals to... Okay. Oh, sorry. This one is 5 times 1 is 5. 2 times 10 is 20. For 10 raised to the power, for the 100 is 6 times 10 raised to the power 2. That means 10 raised to the power 2 is 100. 10 raised to the power 2 means 10 times 10, which is 100. 6 times 100, that becomes 600. So you can see 625. 6, the place value for 100 for the 6, 20 tenths for the 2. That's why it becomes 25 for the units. And each of them is as a result of the power of 10, because this is a decimal system or number or base 10 system of counting. So in other bases, the same rule apply. The same way you have it this way in base 10, you also have it in base 2, or name it any base. Each of the digits will take their own value. The unit will have the base raised to power 0. The next one will have the base raised to power 1. The next one will have the base raised to power 2. If I put 1000 here, it will be the base raised to power 3. If I continue putting other digits, it will be the base raised to power 4. As the digits continue to increase, the power of the base is also increased. So with this, let us see how we can convert numbers in base 10 to base 2, how we can convert numbers in base 10 to other bases, and how we can convert numbers from other bases to base 10. To convert from base 10 to other bases, what we do is what we call expansion method, whereby we multiply. So whenever we want to convert number from base 10 to base 2 or base 8, we use the method called expansion, whereby we multiply. There's multiplication. And when we want to convert from base 10 to other bases or base 2, we use what we call division method. So the first question is, convert 1011 base 2 to base 10. We are to convert this number in base 2 to base 10. And we say when we're converting any number in another base to base 10, we use what we call expansion method. Let's look at it. First of all, we ascribe powers to these digits according to their place value. According to their place value, let me write it out. 1011 base 2. This digit, the place value is 0. That's the unit. The place value, according the way we have explained before, this is 1. This is raised to power 2. This is raised to power 3. So the place value of each of these digits have been listed up: 0, 1, 2, and 3. If I have another digit here, the place value will be 4. So what I'll do is, I know this number is in base 2. And always remember, our bases are always written as subscript, written down. That is subscript to that number. This number is in base 2. I will use the base the number to multiply the base and raise it to the power that indicates its value. So let me start from here. The base is 2, so we're using 2 to multiply. We are using 2 to multiply. 1 times 2 raised to power what? 3. So this one plus 0 times 2, 0 times 2 raised to power 2, plus 1 times 2, 1 times 2 raised to power 1, plus 1 times 2 raised to power 0. 1 times 2 raised to power 0. So you can see I'm using each digit to multiply the base raised to the power that shows the value, the place value of that digit. Okay, 2 raised to power 3 means 2 times 2 times 2, which is 2 times 2, 4, 4 times 2, 8. That's what it means. That means this is 1 times 8 is equal to what? 8. So we have 1 times 8 is 8, plus 0 times any number is 0. 2 raised to the power 2 is 4. That's 2 times 4. 4 times 0 is 0. So any number multiplied by 0 is 0. Plus 2 raised to power 1 is 2. 2 times 1 times 2 is 2. Plus you have 2 raised to power 0. Any number raised to power 0 is 1. If you have 10 to power 0 is 1. 100 to power 0 is 1. So note that one. Once you raise any number to 0, that number becomes 1. So 1 times 1 is 1. So we can now add 8 plus 0 is 8, plus 2, 10, plus 1, 11. So our answer is what? 11. 11 in base 10. So when you convert 1011 base 2, 1011 base 2, it becomes 11 in base 10. Very, very simple. We're going to take further example. We have the next example. Convert 234 base 8 to base 10. And as we all know, we're using what method? Expansion method. So when you look at this number, we're going to put the value to each of them. The place value. This one is 0, 1, 2. So we're going to multiply it. Use each digit as we did it before. We have 3 times 8 raised to the power what? 2, plus 2 times 8 raised to the power 1 times 8 raised to the power 1 plus 4 times 8 raised to the power 0. 4 times 8 raised to the power 0. So we have 8 raised to the power 2 means 8 times 8, 64. 3 times 64 will give me what? 3 times 64 will give me 192. 192 plus 8 raised to the power 1 is 8. 2 times 8 is 16 plus 8 raised to the power 0 is 1. Remember, any number to power 0 is 1. 4 times 1 is 4. So let's add it together. If you add these together, it will give you what? It will give you 212 in base 10. The next example, we are converting 25 base 10 to base 2. And remember, whenever you are converting any number from base 10 to other bases, we use division method. So what do? Let's bring out 25. You bring out what? 25. You divide with the base that you're converting to. If you're converting to base 8, you divide with 8. If you're converting to base 4, you divide with 4. If you're converting to base 2, you divide with 2. So here we're converting to base 2. I'm going to divide with 2. Okay, look at what I'm doing. 2 go into 25. 25 divided by 2. What will it give you? It will give us a 12. Remainder 1. Always take note of the remainder because that will be the important thing I'm going to collect later. 12 remainder 1. 2 will divide 12 again to give us 6 remainder 0. 2 will divide 6 to give us 3 remainder 0. 2 dividing 3 will give us what? 2 divide 3 will give us 1 remainder 1. And 2 into 1 will give us 0 remainder 1. So these remainders are very, very important. We are going to take them upward. Gather the remainders upward. So let our arrow will point upward. That's how we're going to pick this remainder because that will show that will be that number in that base. So we have 11001 base 2. So our answer becomes 11001 base 2. Always remember to write your base down as subscript. That is the answer. So 25 in base 10. When you convert to base 2, it becomes 11001 in base 2. The next example is convert 90 base 10 to base 8. So for us to do it, you know what we do? We have to divide. We have to divide using base 8, using 8. So I have 90, I have 8, the base will divide. So 90 divided by 8, it gives us 8. 8 means 11. It gives us 11 remainder 2. Remainder 2. 11 divided by 8, it will give us 1. Remainder what? Remainder 3. 8 going to 1. That will be 0. Remainder 1. And remember, we pick our remainder upwards. So 90 in base 10 will become 132. 132 base 8. This is very, very simple. The exercise displayed on the screen, go through it and put your answer in the comments. Always remember to rewatch this video over and over wherever you need clarification. See you in my next class. Bye.